If you enjoy untold stories of war and history, make sure to subscribe and join our journey through the past. The freight train arrives in the early afternoon, low clouds hanging over the rail yard, the smell of coal smoke and wet gravel, the sound of wheels grinding to a halt. November 1945, the war in Europe ended 6 months ago, the Pacific War finished 3 months back, but the testing never stops, the evaluation continues, because the next war, if it comes, must find America ready. On flat car number 47 sits something unusual, covered with canvas tarpaulin, roped down, secured with chains. The shape beneath is unmistakable to those who know: low silhouette, wide hull, the distinctive curve of a turret. Railroad workers stand back, smoking cigarettes, watching as military personnel approach, clipboards in hand, orders from Washington still fresh. The officer in charge, a major from the Ordnance Department, walks the length of the flat car, boots crunching on gravel, breath visible in the cold air. He signals to the work crew, 6 enlisted men in wool overcoats, gloves, watch caps pulled low. They climb onto the flat car, begin loosening the ropes, unhooking the chains, the canvas stiff with frost where it touched metal overnight. The tarpaulin comes off in sections, folded, set aside. What emerges is a tank, Soviet-made, captured in Germany during the final push, a T-34 model 1944 with the larger turret, the 85mm gun, the kind that hammered German panzers from Kursk to Berlin. Paint faded, markings half-burned, scratched, muddy, the remnants of a white number barely visible on the turret side, Cyrillic letters stenciled on the hull, worn down to ghosts. The tank sits there, foreign, silent, heavy. Weight 32 tons, length 24 feet including the gun, width 10 feet, height 9 feet, all recorded in the transportation manifest. Steel plates welded at angles, none of the smooth curves of American design, just slabs joined with rough beads of weld metal, functional, brutal, efficient. The armor shows dents, scrapes, one penetration hole in the lower hull, patched with a steel plate welded over it, the repair crude but solid. Diesel fuel smell hangs in the air, old oil, burnt rubber, the particular scent of Soviet lubricants, different from American petroleum products, earthier, heavier. The tracks are worn, some links replaced with German-made pieces, evidence of field repair, of keeping the machine running with whatever was available. Mud caked in the suspension, dried now, European mud mixed with snow melt and engine oil. The crew begins the unloading process, bringing up steel ramps, positioning them at the end of the flat car. The tank must be driven off, no crane here large enough to lift it safely, so it must move under its own power. A sergeant climbs onto the hull, opens the driver's hatch, peers inside, wrinkles his nose at the smell: old sweat, gun oil, leather, metal, the concentrated essence of a crew compartment sealed for months. He drops down inside, disappears from view. Minutes pass, the crew waits, the major checks his watch. Then the sound starts, a coughing rumble, the V2 diesel engine turning over, once, twice, catching, roaring to life with a deep throaty bellow unlike the higher-pitched gasoline engines of American tanks. Black smoke pours from the exhaust, hangs in the cold air, the whole machine shudders, vibrates, settles into an uneven idle, the sound bouncing off the warehouse walls across the rail yard. The sergeant's head appears from the hatch, he waves, the major signals forward, the unloading begins. Tracks clank against the steel ramps, metal on metal screech, the T-34 lurches forward, rocks, steadies, moves down the incline with surprising smoothness despite the rough idle. At the bottom it pivots, treads grinding gravel, swings around to face the road leading to the proving ground proper, stops, engine idling, waiting. 2 jeeps pull up, military police, an escort, standard procedure for captured equipment. The convoy forms, 1 jeep leading, the T-34 following, the second jeep behind. They move out slowly, the tank limited to road speed, maybe 20 miles per hour, the tracks loud on the paved road, the engine note echoing off trees lining the route. Personnel stop and stare as it passes, this machine that fought on the other side of the world, now here in Maryland, about to give up its secrets. Dawn comes cold and clear the next morning, frost on every surface, grass white and crunching underfoot, the sky pale gray turning pink at the horizon. Hangar 7 stands at the east end of the proving ground, a massive steel structure built in 1918, high ceiling, concrete floor stained with decades of oil and hydraulic fluid, the smell of metal and lubricant permanent in the air. Inside, under banks of lights, the T-34 sits centered on the floor. Around it stands a group of 15 men, engineers, ordnance officers, technical specialists, some from the Army, some from private manufacturers, all with security clearance, all sworn to discretion. They wear a mix of uniforms and civilian clothes, carrying notebooks, cameras, measuring tools, their breath visible in the unheated hangar. The senior engineer, a lieutenant colonel named Morrison, addresses the group, voice echoing in the space. His words are brief, factual, stripped of unnecessary detail. This is Technical Intelligence Report 45-37, Evaluation of Captured Soviet Medium Tank T-34 Model 44, Purpose is Complete Technical Analysis, Comparison with Current U.S. and Known German Designs, Assessment of Manufacturing Techniques, Combat Effectiveness, Mechanical Reliability. Duration of testing, estimated 6 weeks, December 1945 through January 1946. The men disperse, begin their work. Photographers set up their equipment, large format cameras on tripods, flash units ready, each angle documented, each detail preserved on film. The clicking of shutters, the flash of bulbs, white light reflecting off curved steel, the shadows deep and sharp in the directed illumination. Close-ups of weld seams, the turret ring, the gun mantlet, the driver's vision port, the engine deck, the track links, everything recorded with methodical precision. Others take measurements, metal tape measures stretched across the hull, calipers checking armor thickness where possible, notebooks filling with numbers. Whole front armor 45 mm at 60 degrees from vertical, effective thickness approximately 90 mm. Side armor 45 mm vertical, top armor 20 mm, bottom armor 20 mm. Turret front 90 mm curved, turret side 75 mm, turret rear 60 mm. Gun mantlet 90 mm. All measured, all recorded, all compared mentally to the Sherman specifications, the Sherman with its 50 mm front at 56 degrees, effective thickness 75 mm, already known to be vulnerable to German guns. A mechanical engineer named Captain Hendricks crawls underneath, flashlight in hand, examining the suspension, the transmission housing, the belly armor. He emerges dusty, smudged with old grease, makes notes about the Christie suspension system, the large road wheels, the absence of return rollers, the simplicity of the design, fewer parts than the Sherman's vertical volute spring suspension, fewer things to break, easier to maintain in field conditions. Another engineer studies the tracks, noting the width, 560 mm, wider than Sherman tracks at 421 mm, better weight distribution, lower ground pressure, better performance in mud and snow. The track links are manganese steel, hard, durable, each link weighs 35 pounds, simple pin connectors, no rubber pads, just metal on metal, noisy but indestructible, impossible to wear out in normal use. The turret draws particular attention, its size, its shape. The newer T-34 with the 85 mm gun required a larger turret, 3 men now instead of 2 in the earlier models, still cramped but workable. The main gun is the ZIS S-53, 85 mm bore diameter, 54 calibers long, total length 4.6 meters, firing a 9.2 kg armor-piercing round at 790 meters per second muzzle velocity, capable of penetrating 100 mm of armor at 1,000 meters range. Numbers that make the Sherman 75 mm gun look inadequate, outclassed. The gun elevation mechanism is manual, no hydraulics, just gears and muscle, the gunner cranking a wheel to raise or lower the barrel. The traverse is also manual, but a small electric motor assists, powered by the tank's electrical system, making rotation easier, faster than pure manual traverse. American engineers note this, the combination of simple manual backup with electrical assistance, reliable, maintainable, less likely to fail than a fully hydraulic system. Morning stretches into afternoon, the work continues without pause, cigarette smoke drifting under the lights, thermoses of coffee passed around, sandwiches eaten standing up, no one wanting to stop, the fascination too great, the discoveries too important. This tank represents Soviet thinking, Soviet industrial capacity, Soviet design philosophy, all visible in steel and machinery, no propaganda required, just the physical reality of what they built. The third day, the engineers turn their attention to the power plant, the V2 diesel engine, 38.8 liters displacement, 12 cylinders in a 60-degree V configuration, 500 horsepower at 1800 revolutions per minute, the engine that propelled thousands of T-34s across Europe. To examine it properly, they must remove it from the hull, a process requiring a crane, tools, several hours of work. The engine deck opens on hinges, large panels of armor plate swinging up to reveal the engine compartment, cramped, packed tight with machinery, fuel tanks, oil reservoir, radiators, fan, transmission linkage, all fitted together like a three-dimensional puzzle. The smell intensifies, diesel fuel, hot metal, synthetic oil, rubber seals, the concentrated essence of mechanical operation. 6 men work to disconnect everything, fuel lines, oil lines, coolant lines, electrical connections, mechanical linkages, each connection marked with chalk to remember the assembly sequence. The work proceeds slowly, carefully, these men familiar with American engines but encountering Soviet engineering for the first time, the threads different, metric instead of standard, the fittings designed for different wrenches, the layout foreign. The crane hooks attached to lifting points on the engine block, chains tighten, take the weight, 3 tons of iron and steel rising slowly from the compartment, swinging free, lowering onto a wheeled stand prepared beside the tank. The engine sits there, exposed, raw, powerful even motionless, oil dripping from the pan, coolant leaking from disconnected hoses, puddles forming on the concrete. An engine specialist named Lieutenant Baker begins the detailed examination, walking around it, touching components, spinning the cooling fan by hand, checking the fuel injection pump, the distributor, the air intake. He dictates observations to a stenographer who types rapidly, the clack of typewriter keys echoing in the hangar. Engine construction appears crude, casting rough, machining adequate but not refined, no polishing, no aesthetic consideration, purely functional design, yet clearly effective as evidenced by operational status after transport and storage. The crankcase is aluminum, unusual. American tanks use cast iron for durability, but aluminum saves weight, 200 pounds lighter than equivalent iron casting, and the Soviets have abundant aluminum from their industrial base. The cylinder heads are also aluminum, the block itself iron, a hybrid design balancing weight and strength. Baker removes the valve covers, exposing the camshafts, the valve train, overhead cam design, efficient, compact, 4 valves per cylinder, modern engineering despite crude execution. The valves themselves are larger than in comparable American engines, better breathing, higher volumetric efficiency, contributing to the impressive power output from a relatively small displacement. The fuel injection system is mechanical, no electrical components, a governor controls engine speed, simple, reliable, insensitive to temperature extremes. The fuel pump is driven directly off the engine, positive displacement design, will work in any climate, any altitude, any condition. Baker notes this admiringly, recognizing the genius of simplicity, how removing electrical complexity eliminates failure points, makes the engine soldier-proof, maintainable by mechanics with minimal training. Compression test next, each cylinder checked with a gauge screwed into the spark plug hole, except these are diesel engines, no spark plugs, glow plugs instead for cold starting. Compression test requires removing injectors. The readings come back consistent, cylinder-to-cylinder variation less than 5%, indicating good manufacturing quality control despite rough appearance, the important tolerances held precisely, the cosmetic finish ignored. The cooling system receives attention, liquid-cooled, 2 radiators mounted in series, large cooling capacity for operating in hot climates, summer on the Russian steppe, desert conditions in the Middle East if exported there. The fan is huge, diameter 30 inches, moves massive air volume, powered directly off the engine crankshaft through gears, no belt to slip or break, another example of robust design prioritizing reliability. Oil system next, the engineers drain the sump, measure capacity, examine the oil pump, check the filtration. The oil is thick, viscous, dark brown, Soviet specification, different chemistry than American oils, higher viscosity at cold temperatures, designed for extreme winter conditions, -40 degrees Fahrenheit and colder, temperatures that would freeze American oil solid, immobilize American tanks. This oil stays fluid, pourable, functional, a critical advantage in winter warfare. The examination takes all day, into evening, the engineers working under portable lights as darkness falls outside, their shadows long on the hangar walls, the clink of tools, the scratch of pencils on paper, measurements recorded, observations noted, conclusions forming. This engine is not sophisticated, not refined, but it is brilliant in its pragmatism, built for mass production, for operation by minimally trained crews, for maintenance in field conditions with limited tools, for survival in climates that would kill more delicate machines. It is an engine designed for total war, for a nation fighting for its existence, where perfection is the enemy of adequate, where good enough produced in quantity beats excellent produced in scarcity. December arrives with snow, 6 inches overnight, the proving ground transformed into white silence, trees heavy with accumulation, the test roads covered, only the tank trails visible as dark lines through the whiteness. Morning temperature 18 degrees Fahrenheit, wind from the northwest, clear sky, perfect conditions for mobility testing in winter terrain. The T-34 sits at the starting line of the test course, engine running, exhaust smoking in the cold air, the commander's hatch open, a U.S. Army test driver visible from the waist up, wearing Soviet-style padded tanker's helmet found inside the vehicle, practical, warmer than standard American headgear. The driver is Sergeant First Class Williams, 28 years old, tank driver since 1943, European theater veteran, experienced with Shermans, familiar with captured German tanks, but this is his first time in a T-34. The test course stretches 2 miles ahead, marked with flags, including obstacles, grades, trenches, water crossings, designed to simulate battlefield conditions. Observation posts at intervals, equipped with stopwatches, measuring instruments, cameras, teams of engineers recording every aspect of performance. The radio crackles, Morrison's voice authorizing commencement of test sequence alpha, mobility and handling evaluation. Williams closes the hatch, the tank lurches forward, tracks biting into snow, throwing up white spray behind, acceleration immediate, surprising, faster than expected. The T-34 moves across the flat section at increasing speed, 15, 20, 25 miles per hour, tracks humming, suspension absorbing the rough ground, the ride apparently smooth based on the stable gun barrel, not bouncing or oscillating. First obstacle, a trench 6 feet wide, standard anti-tank ditch dimension. The T-34 approaches at speed, doesn't slow, hits the edge and crosses in one fluid motion, the long hull bridging the gap, tracks never losing contact, emerging on the far side without pause. Observers note this, the Sherman requires more careful approach, slower speed, sometimes gets stuck if not perfectly aligned, but the T-34 treats it as nothing, barely noticeable. Second obstacle, slope, 30-degree grade, 50 yards long, snow-covered, appears slippery. The T-34 attacks it straight on, engine roaring, black smoke pouring, tracks spinning momentarily then gripping, the tank climbing steadily, no hesitation, reaching the top, pausing on the crest, silhouette stark against the pale sky, then tipping forward, descending the far side in controlled slide, tracks locked, using the transmission as brake, arriving at the bottom and immediately accelerating away. Third obstacle, soft ground, mud beneath snow, marked with warning flags because vehicles get stuck here regularly. The T-34 enters at moderate speed, the wide tracks keep it on top, the suspension flexing, individual road wheels rising and falling independently, maintaining track contact, the tank plowing through what would bog down narrower tracked vehicles, emerging on firm ground without drama. The radio reports continue, observers calling in times, speeds, performance notes. Williams pushes harder, testing limits, accelerating to maximum road speed, 35 miles per hour indicated on the crude speedometer, the tank vibrating, tracks roaring, suspension at maximum deflection on the rough surface, but holding together, nothing breaking, nothing failing. Steering test next, full speed turn, Williams cranks the left steering lever, the left track brakes while the right continues, the tank pivots violently, slewing sideways, throwing up snow, completing a 180-degree turn in its own length, stopping, reversing the process, turning the other direction, demonstrating the agility possible with clutch brake steering, the ability to change direction instantly, crucial in combat when dodging fire. The water crossing is partially frozen, creek 20 feet wide, ice on the edges, current visible in the center, depth 4 feet. The T-34 approaches, doesn't stop, enters the water at speed, tracks churning, throwing spray, the bow wave rising, water over the fenders, the tank keeps moving, claws up the far bank, emerges streaming water from the suspension, continues forward without pause, the sealed hull keeping the crew compartment dry, the engine breathing through a snorkel that extends above water level. Hours pass, the tests continue, fuel consumption measured, track wear examined after each run, mechanical systems checked for problems, none found, the tank performs reliably, repeatedly, no breakdowns, no failures, no mechanical difficulties despite hard use, despite cold conditions, despite rough handling. The engineers' respect grows with each successful test, this machine clearly designed by people who understood warfare, who knew what tanks face in combat, who prioritized reliability over refinement. Late afternoon, the sun low, temperature dropping, the final test begins. Maximum endurance run, continue until fuel exhaustion, measure total range, average speed, mechanical durability. Williams drives the test course repeatedly, lap after lap, the tank circling the proving ground like a mechanical beast, tireless, relentless, the engine note never changing, the exhaust never showing distress, the tracks never faltering. Darkness falls, the tank continues under its own headlights, primitive by American standards, single bulbs in metal housings, but adequate, sufficient, good enough. The headlights sweep across snow, illuminate trees, cast long shadows, the tank a moving island of light in the winter night, the sound of its passage audible across the frozen ground, rumbling, mechanical, purposeful. Finally, 300 kilometers traveled, 186 miles, the fuel gauges approach empty. Williams brings the T-34 back to the starting point, shuts down the engine, climbs out stiff and cold but impressed. He tells the engineers waiting that the tank drives like a truck, heavy, direct, the controls requiring physical effort but responsive, predictable, the visibility poor from the driver's position but manageable, the overall impression one of brutal effectiveness, a machine that does its job without complaint. The firing range at Aberdeen extends across 200 acres of flat ground, impact berms at the far end, observation bunkers protected by earthworks, the smell of burnt powder perpetual in the air, brass casings littering the ground like brass grass. Here vehicles come to die, to be shot, penetrated, destroyed in the name of technical knowledge, understanding failure modes, determining protective value. The T-34 sits 500 meters downrange, positioned broadside to the firing line, the turret rotated to present maximum profile, the target marked with white paint crosses on the hull, on the turret, aiming points for the gunners. The tank appears somehow vulnerable now, stationary, passive, awaiting destruction after proving its mechanical worth, the final sacrifice in the name of science. In the firing bunker, Lieutenant Colonel Morrison and his team gather around the viewing slits, binoculars ready, cameras positioned, measuring instruments prepared. The test sequence calls for engagement with standard U.S. anti-tank weapons, starting with the 3-inch gun M5, progressing to the 90mm gun M3 if necessary, determining penetration capability, armor effectiveness, comparative protection versus American tanks. The 3-inch gun sits in its emplacement, crew standing ready, the weapon a towed anti-tank gun used throughout the European campaign, firing a 15-pound armor-piercing projectile at 2,600 feet per second muzzle velocity, capable of defeating most German tanks at normal combat ranges. The question now, how does it perform against Soviet armor, the sloped plates of the T-34, the design that proved so effective against German guns? The command given, fire when ready, the gunner adjusts elevation, traverses slightly, settles on the first aiming point, lower hull front plate. The gun fires, sharp crack echoing across the range, the recoil violent, the gun barrel rocketing backward against the recuperator, the smoke and flame erupting from the muzzle, the shell visible for an instant as a streak, then impact. The sound reaches the bunker a second later, metallic clang, observers focus binoculars, see the strike point, white paint blasted away, bare metal showing, but no penetration, the shell deflected upward by the 60-degree slope of the armor, the kinetic energy redirected, the plate intact. The crew fires again, same result, the 3-inch gun unable to defeat the front armor at this range, the sloped design proving its worth, effective thickness too great. Target shift, side armor, vertical plates, less protection, theoretically vulnerable. The gun crew adjusts, fires, impact on the hull side, this time penetration, the shell punches through, the hole visible even from 500 meters, clean entry, ragged exit on the far side. The observers note this, side armor vulnerable to 3-inch gun, but tanks in combat present front armor when possible, the side shot requiring flanking maneuver, tactical advantage. Next weapon, the 90mm gun M3, mounted in the M36 tank destroyer, more powerful than the 3-inch, firing a 24-pound projectile at 3,000 feet per second, designed to defeat the heaviest German armor encountered. The gun is wheeled into position, crew loads, aims at the turret front, the thickest armor on the T-34, 90mm of curved steel. Fire command, the 90 roars, massive recoil, enormous muzzle blast, the shell screams downrange, strikes the turret dead center. The sound is deeper, heavier, observers see the impact, the turret rocks from the strike, but holds, the shell penetrated, punching completely through, but the armor didn't shatter, didn't spall catastrophically, the whole clean, the surrounding material intact, structural integrity maintained. The comparison forms in the observers' minds, Sherman armor at similar thickness would likely have suffered worse, the softer American armor steel more prone to spalling, sending fragments through the interior, killing crew members even without complete penetration. The Soviet armor is harder, more brittle, but surprisingly resistant to catastrophic failure, another design choice favoring battlefield survival. More shots, different angles, different impact points, each strike measured, photographed, analyzed. The pattern emerges clearly, the T-34's armor is not impenetrable, modern U.S. anti-tank weapons can defeat it, but the sloped design provides excellent protection for the weight, maximizing effectiveness of relatively thin plates, a lesson in efficient engineering, doing more with less. The German perspective becomes understandable, why Wehrmacht tankers feared the T-34, why it earned respect despite crude finish, why it succeeded where more sophisticated German designs failed. The combination of adequate armor, properly sloped, mounted on a reliable chassis with good mobility and powerful gun created a balanced design, no weak points easily exploited, no obvious flaws to target, just a solid, competent fighting vehicle produced in overwhelming numbers. The firing ceases, the range goes quiet except for the wind, the T-34 sits punctured, smoking slightly from interior fires started by the penetrations, but still recognizable, still intact, not disintegrated, not destroyed beyond recognition, damaged but dignified somehow, bearing its wounds like medals earned. The engineers emerge from the bunker, walk downrange to examine the damage close up, measuring entry holes, exit holes, checking for cracks, for spalling, for structural damage beyond the immediate penetrations. Captain Hendricks climbs onto the hull, looks into a penetration hole, sees the interior carnage, equipment destroyed, ammunition storage penetrated, fuel tank holed, everything that would kill a crew in combat, but the tank itself remains functional in structure, could be repaired if recovered from battlefield, put back into service with new components, the basic chassis sound. He makes notes, comparing mentally to Sherman casualties he saw in Europe, tanks burned beyond salvage, turrets blown off by ammunition fires, holes cracked by penetrations, the T-34 seeming more survivable somehow, despite equal damage. The main hangar now holds 2 tanks, the T-34 battle-damaged but complete, and beside it a standard M4A3 Sherman, fresh from production, painted in olive drab, clean, proper, representing American tank design philosophy at war's end. The contrast is immediate, striking, 2 machines built for the same purpose, emerging from different worlds, different thinking, different priorities. The Sherman is taller by 2 feet, a significant difference, making it more visible on the battlefield, easier to spot, easier to hit, the higher profile necessary to accommodate the radial aircraft engine mounted vertically in the hull, the design chosen for power availability when tank-specific engines were scarce in 1942. The T-34 sits lower, sleeker, the diesel engine mounted horizontally, allowing lower hull height, smaller target, tactical advantage. The Sherman is wider, heavier, 33 tons combat loaded versus 32 for the T-34, but carries less armor, the weight going into internal complexity, ammunition storage, crew comfort, the 5-man crew having more room than the 4-man Soviet crew, the American design prioritizing crew efficiency, crew survival through ergonomics, the Soviet design prioritizing armor, firepower, accepting cramped conditions as acceptable trade-off. The Sherman's armor is better made, better finished, the welds neat, the plates machined smooth, the attention to detail evident in every joint, every seam, the quality control higher, the rejection rate for defective armor presumably much lower than Soviet standards. But the armor is mounted differently, less slope on the front plate, 56 degrees versus 60, reducing effective thickness, and the overall protection is less despite better materials, the Soviet design compensating for production limitations through geometry, through angles, through clever application of basic physics. The guns tell the story most dramatically. The Sherman mounts a 75mm M3 gun, 40 calibers long, firing a 15-pound shell at 2,000 feet per second, adequate against early German tanks, increasingly inadequate by war's end against Panthers and Tigers, requiring special tungsten core ammunition to achieve penetration, ammunition in short supply, rationed carefully. The T-34's 85mm gun outclasses it completely, longer range, higher velocity, better penetration, using standard steel ammunition, no special materials required, the Soviet industrial capacity supporting the design. The Sherman's engine is gasoline-powered, the Ford GAA V8, later models, 500 horsepower, powerful, smooth, refined, but gasoline is dangerous, burns easily, explodes when penetrated, the Sherman's reputation as a death trap partly stemming from fuel fires after penetration. The T-34's diesel is safer, diesel fuel less volatile, fires less catastrophic, crew survival rates higher after being hit, the Soviet choice of diesel reflecting combat experience, prioritizing survivability over engineering convenience. The Sherman's transmission is complex, synchromesh gearbox, 5 forward speeds, smooth shifting, easy to drive, reducing driver fatigue, allowing less trained operators to function effectively, the American way prioritizing operator ease, accepting mechanical complexity as necessary cost. The T-34's transmission is crude, crash gearbox, for speeds, heavy clutch, difficult shifting, requiring skill and strength, but simple, rebuildable in field conditions with basic tools, the Soviet way prioritizing maintainability, accepting operator difficulty as acceptable trade-off. The Sherman has better vision devices, periscopes, vision ports, the commander's position excellent, visibility in all directions, allowing tactical awareness, the ability to spot threats early, to coordinate with other tanks, to command effectively. The T-34's vision is poor, narrow slits, limited periscopes, the commander serving also as gunner in early models, only the later 85mm version having separate commander position, and even then cramped, restricted, the Soviet design accepting reduced awareness as cost of lower profile, better armor protection. The engineers document all this, photographs side by side, measurements compared, specifications listed in parallel columns, the two design philosophies clear, distinct, reflecting national characters, industrial capabilities, tactical doctrines. The American tank is better for its crew, safer to operate, easier to fight from, more likely to bring them home alive from a single engagement, the design showing care for the individual, the value placed on trained personnel, the replacement difficulty when casualties occur. The Soviet tank is better for the war, cheaper to produce, faster to manufacture, easier to repair, more suitable for mass production in factories with lower skill workers, the design showing acceptance of casualties, of crew expendability, of the need to produce maximum combat power from limited resources, the reality of fighting for national survival against an invader willing to kill everyone, destroy everything. Neither design is wrong, both are correct for their contexts, their purposes, their circumstances. The Sherman won battles with its superior crew efficiency, its reliability, its ease of operation, the American logistical system keeping it supplied, maintained, repaired, the replacement crews trained, equipped, inserted into combat quickly. The T-34 won campaigns with its numbers, its simplicity, its suitability for production in evacuated factories operating under bombardment, using unskilled labor, producing thousands of tanks to replace thousands lost, the Soviet system grinding down the Wehrmacht through attrition, through relentless pressure, through accepting losses that would break other armies. The report being written will say all this, diplomatic in language but clear in meaning, the technical comparison revealing deeper truths about nations, about warfare, about the different paths to victory in modern industrial conflict. Evening in the hangar, December twilight outside, the lights bright inside, Major Wilson from Army Ordnance sits at a desk covered with reports, photographs, test data, writing the summary section of Technical Intelligence Report 45-37. He pauses, pen suspended, thinking about what the 6 weeks of testing revealed, what conclusions matter, what insights have value beyond pure technical specification. The T-34 is not a better tank than the Sherman, not in any absolute sense, not in any single measurable category except gun power, but it is a better tank for the Soviet Union, for their industrial base, for their tactical situation, for their way of war. This distinction is crucial, the understanding that good design is contextual, relative, that the perfect tank for America would be wrong for Russia, that comparing specifications misses the point. The Soviet design philosophy is revealed completely in this machine, every choice, every compromise, every unusual feature speaks of a nation mobilized totally, fighting desperately, converting entire economy to war production, using every resource available, accepting nothing as impossible. They chose diesel engines because they controlled oil fields producing crude oil better suited to diesel fuel than gasoline, because diesel is safer, because the choice saved refining capacity for aviation gasoline, for trucks, for other military needs. They chose sloped armor because it maximized protection from limited steel supplies, because it was proven in combat, because the mathematics favored it. They chose simple construction because it allowed rapid training of workers, because it used materials available domestically, because it enabled dispersed production in small factories, in tractor plants, in facilities never intended for tank production. Every feature traces back to total war, to national survival, to fighting an enemy who takes no prisoners, who exterminates populations, who must be stopped regardless of cost. The T-34 is a weapon of desperation forged into effectiveness, a machine born from necessity, refined through catastrophe, produced in quantities that beggar imagination, 50,000 or more built during the war, equipping armies measured in millions, replacing losses measured in thousands weekly, the numbers beyond American conception. Wilson thinks about the implications for the future, for the growing tension with the Soviets, for the possibility of conflict, the unthinkable war that some are beginning to discuss in Washington, in planning offices, in classified conferences. If war comes, America will face this machine in vast numbers, operated by a military that proved capable of destroying the Wehrmacht, that took casualties no democracy could sustain, that kept fighting through disasters that would collapse other armies. The T-34 is not the best Soviet weapon, just the most visible symbol of their capability, their determination, their willingness to pay any price. He writes carefully, knowing this report will be read by generals, by politicians, by planners determining future policy, future procurement, future strategy. The temptation exists to dismiss Soviet technology as crude, as inferior, as beneath serious consideration, the temptation to assume American superiority, American invincibility, American certainty of victory in any future conflict. But the T-34 proves otherwise, proves that crude can be effective, that simple can be superior, that different doesn't mean worse. The Sherman is a peacetime design adapted to war, built by a nation with luxury of time, of resources, of geographic security, fighting wars on other continents, projecting power across oceans, supporting allies, tipping balances, but never facing extinction, never risking invasion, never confronting elimination as a people. American tanks can afford comfort, complexity, refinement, because American factories are safe, American training camps operate without enemy bombers overhead, American supply lines stretch across friendly territory, American replacements arrive trained and equipped. The T-34 is a wartime design, pure and absolute, built by a nation invaded, with enemies on its soil, with cities besieged, with millions dead, with survival uncertain, with no time for perfection, no resources for luxury, no tolerance for complexity that doesn't contribute directly to killing enemies, to surviving combat, to winning battles. Soviet tanks must be simple because factory workers are teenage girls and old men, must be maintainable because mechanics are conscripts with minimal training, must be cheap because steel is scarce, must be produced in quantity because losses are catastrophic. Wilson concludes the section with a warning, carefully phrased, professionally neutral, but clear to anyone reading with attention. The Soviet Union has demonstrated capability to produce effective weapons in mass quantities using limited resources under extreme conditions, and to continue improving these weapons based on combat experience. They have demonstrated willingness to accept casualties and losses beyond Western tolerance, and they have demonstrated tactical and operational competence sufficient to defeat the Wehrmacht, previously considered the world's most effective military. Therefore any future conflict must account for these factors, must not assume technological superiority alone provides victory, must recognize that numbers, determination, and adequate equipment may overcome quality, sophistication, and refinement. January 1946, the testing officially concludes, the report enters typing, the T-34 sits in the hangar awaiting decision on disposition, whether to preserve it for future reference, to display it for training, to continue testing to destruction, or to simply scrap it, recover the steel, move on to the next evaluation, the next captured weapon, the next intelligence requirement. Before that decision, one final evaluation, informal, personal, requested by the test drivers, the mechanics, the engineers who worked with the tank for 6 weeks, who came to respect it, who want to understand it fully, who ask permission to conduct a road march, a final drive across the Maryland countryside, to experience it as its original crews did, as a machine of movement, of action, of war. Permission granted, the conditions set, daylight hours, observers following, route approved, safety precautions in place. The morning comes cold, clear, the ground frozen hard, perfect for cross-country movement. Sergeant Williams will drive again, Captain Hendricks will command from the turret, 2 others will crew the loader and bow gunner positions, the full 4-man complement, experiencing the reality of operating the vehicle in something approaching combat conditions. They mount up, settle into positions, the crew compartment cramped, crowded, smelling of metal and oil and exhaust fumes seeping through imperfect seals. The seats are thin padding over metal, uncomfortable within minutes, the controls heavy, requiring constant effort, the visibility poor, restricted, each man seeing only a slice of the world through his assigned vision device, the overall tactical picture assembled mentally from fragments, from voice communication, from experience. The engine starts, the sound inside deafening, no acoustic insulation, no sound deadening, just metal walls and metal floor amplifying the diesel roar, the vibration transmitted directly through the structure into bones, into teeth, into skull. Conversation requires shouting, radio communication barely possible, the intercom system minimal, crude, prone to static, to cutting out, to failure. Williams engages the transmission, first gear, the tank lurches forward, tracks clanking, suspension banging, every bump, every hole, every irregularity transmitted through the thin padding into the crew, no smooth ride, no comfortable travel, just brutal mechanical motion. They drive out of the proving ground, onto secondary roads, trying to imagine rolling across the Russian steppe, across the Ukraine, across Poland, across Germany, day after day, week after week, the cumulative fatigue, the physical beating, the mental strain, the constant noise, the cold in winter, the heat in summer, the cramped positions, the lack of relief. The reality of tank warfare as experienced by men who fought thousands of miles in these machines. The countryside passes, farms, fields, woods, the winter landscape peaceful, quiet, the war over, the tension gone, but inside the tank the war continues. The machine imposes its demands, its discomforts, its requirements, testing the crew, proving that operating this vehicle is work, hard physical labor, requiring strength, endurance, tolerance for punishment, dedication to mission beyond personal comfort. Hendricks rotates the turret, training the gun left and right, experiencing the manual traverse system, the effort required, the slow rotation speed, the need to anticipate target movement, to lead shots, to judge range without sophisticated optics, without ballistic computers, with only simple telescopic sight and practiced eye. He tries the elevation wheel, raising the barrel, lowering it, feeling the weight, the balance, the mechanical advantage, understanding why Soviet gunners needed strength, needed practice, needed talent to achieve accuracy, to hit targets at combat ranges. The loader's position is worst, cramped behind the gun breech, surrounded by ammunition, the shells heavy, awkward, requiring lifting, rotating, inserting into the breech, the physical effort multiplied over dozens of rounds in a sustained engagement, the loader working constantly, frantically, desperately, keeping the gun fed, keeping the tank fighting, the most physically demanding crew position, usually assigned to youngest, strongest member. Hours pass, they drive perhaps 50 miles, crossing varied terrain, stopping periodically to rest, to relieve the physical strain, to exit briefly, to stretch, to breathe fresh air, then mounting again, continuing, the final return to Aberdeen in afternoon, the tank trail-worn, dirty, smoking slightly, running rough now, the crew exhausted, battered, profoundly educated about the reality of armored warfare from the Soviet perspective. They dismount, stiff, bruised, ears ringing from the noise, hands cramped from gripping controls, backs aching from the thin seats and constant jolting, and to a man they agree, operating this vehicle in combat requires toughness beyond the physical, requires mental discipline to endure the conditions, to continue functioning, to keep fighting when every instinct says stop, rest, escape the iron prison, breathe, live. And they understand what Soviet tankers achieved, driving these machines from Moscow to Berlin, surviving not just enemy fire but the vehicle itself, the mechanical nightmare of noise and vibration and discomfort, and still functioning, still fighting, still winning. The respect is complete, total, unqualified, not for the machine alone but for the men who crewed it, for the nation that produced it, for the army that employed it, for the achievement it represents, victory through endurance, through simplicity, through numbers, through acceptance of hardship, through refusal to quit regardless of cost. February 1946, Technical Intelligence Report 45-37 is completed, classified secret, distributed to authorized recipients, filed in archives for future reference. The conclusions are technical but the implications strategic, the details matter but the overview matters more, and what emerges from 6 weeks of intensive testing is a picture of Soviet capability that surprises, impresses, and concerns the American military establishment. The T-34 represents mature design, refined through years of combat, incorporating lessons learned at terrible cost, evolving from early crude versions to later sophisticated examples while maintaining essential simplicity, essential producibility, essential suitability for Soviet conditions. It is not perfect, has definite weaknesses, vulnerabilities that can be exploited, but it is effective, proven in the most demanding test possible, combat against the Wehrmacht across thousands of miles, hundreds of battles, years of sustained warfare. The design philosophy evident in every component reflects total war, national mobilization, prioritization of quantity over quality where quantity matters more, acceptance of adequate over optimal where optimal is unattainable, focus on reliability over refinement where reliability determines survival. American designers can learn from this, can incorporate lessons into future development, but cannot simply copy, because Soviet and American circumstances differ fundamentally, require different solutions, different trade-offs, different priorities. The production methods inferred from construction details suggest industrial capacity exceeding previous American estimates, manufacturing techniques adequate for mass production, quality control sufficient for military purpose, worker skill levels adequate with proper design simplification. The Soviets can produce tanks in quantity, can sustain production under difficult conditions, can replace losses, can equip massive armies. This capability is real, proven, continuing in peacetime as the Red Army maintains strength, modernizes equipment, prepares for unknown future. The tactical effectiveness demonstrated in combat, documented in German reports, confirmed by Allied observers, validated by the vehicle's existence as the dominant Soviet tank design, proves that Soviet military doctrine is sound, Soviet commanders competent, Soviet troops capable of utilizing equipment effectively, achieving objectives, winning battles. The notion of Soviet military inferiority is discarded, replaced by respect, by caution, by recognition that any future conflict with this opponent will be costly, difficult, uncertain in outcome. The strategic implications extend beyond technical comparison, beyond tank versus tank evaluation, toward fundamental questions about American security, American defense policy, American military posture in the post-war world. The Soviet Union is not a technological inferior, is not militarily incompetent, is not a negligible threat, and the weapons they produce, while different from American designs, are effective for their purposes, suitable for their doctrine, adequate for their needs. The Cold War is beginning, though not yet named, not yet recognized as the defining conflict of the next half-century, and this report, this technical evaluation of one captured tank, contributes to the understanding, the awareness, the realization that the wartime alliance is fragmenting, that tensions are rising, that potential exists for conflict, and that such conflict would be unlike anything America has faced before, against an enemy with continental depth, massive population, proven military capability, and weapons like the T-34, crude but effective, simple but deadly, produced in quantities that could overwhelm quality through sheer numbers. The report ends with recommendations, technical suggestions for future American tank development, incorporation of sloped armor, consideration of diesel engines, emphasis on mechanical simplicity, but the deeper recommendation is unstated, present only between the lines, readable by those who understand, that America must remain vigilant, must maintain technological edge, must continue innovation, must not become complacent, must recognize that the next war, if it comes, will not be won easily, quickly, or cheaply, that the enemy has learned, has adapted, has proven themselves formidable, and that American victory is not guaranteed by industrial might alone, requires matching determination, matching sacrifice, matching willingness to pay the price of survival. The T-34 sits in storage now, preserved for history, cleaned, painted, maintained in static display condition, a museum piece, a teaching tool, a reminder, moved eventually to Fort Knox, later to Aberdeen Museum, later still to who knows where, passing through the decades as relic of a war concluded, of a test completed, of a moment when American engineers looked carefully at Soviet design and found it worthy of respect. Winter evening at Aberdeen, the present receding into past, the test complete, the knowledge gained, the lessons recorded, the tank sitting silent in the gathering darkness, engine cold, crew absent, purpose fulfilled. Snow begins to fall, light flakes drifting down, settling on the armor, on the gun barrel, on the tracks, erasing the marks of testing, covering the scars of battle, whitening the metal until the machine becomes a shape, a shadow, a ghost. The proving ground empties, personnel departing, lights extinguishing, buildings closing, the routine of military installation evening, the transition from activity to rest, from work to waiting, the eternal military rhythm of hurry and wait, of intensity and boredom, of crisis and calm. The tank remains, solitary, abandoned temporarily, waiting for morning, for the resumption of study, for the continuation of analysis, for the endless process of understanding, evaluating, comparing, learning, that characterizes military intelligence, that defines the search for advantage, for edge, for the increment of superiority that means survival in combat. But tonight, this moment, this hour, the T-34 rests, its testing concluded, its purpose served, its contribution made to American understanding of Soviet capability, of the machines that conquered Berlin, of the army that broke the Wehrmacht, of the nation that survived invasion, that paid the terrible price, that emerged victorious through suffering, through sacrifice, through determination beyond Western comprehension. The snow continues, the night deepens, the temperature drops, the proving ground becomes landscape again, hills and trees and fields under snow, the tanks just shapes, metal masses, artifacts of human conflict, tools of destruction rendered harmless by inactivity, by stillness, by the absence of war, at least for now, at least in this place, at least in this moment of peace purchased by victory, of quiet bought with blood, of rest earned through survival. Morning will come, testing will resume, the analysis will continue, the reports will multiply, the knowledge will accumulate, the preparation for future conflict will proceed, because that is the nature of nations, of militaries, of the eternal human tragedy that is war. But tonight, in this evening snowfall, in this moment of quiet, the captured T-34 sits at peace, its war concluded, its story written, Its place in history secure, crude steel and simple design that helped win the greatest war. That proved adequate to the test, that carried crews to victory, that survived, that endured, that remains. The sound of wind through bare trees, the soft hiss of snow falling, the creak of metal contracting in the cold, the distant rumble of traffic on the Baltimore road, the faint glow of lights from the installation buildings, the darkness settling over the frozen ground, and in the center of it all, the tank, Soviet steel on American soil, a monument to the strange alliance that was, to the coming confrontation that will be, to the moment when two powers assessed each other with clear eyes and no illusions, when American engineers tested Soviet design and found it formidable, when respect replaced contempt, when understanding replaced assumption, when the truth emerged from measurement, from calculation, from the cold data of science applied to machines of war. The report exists in archives, classified decades, declassified eventually, available now to historians, to researchers, to anyone interested in technical details of weapons that shaped the mid-20th century, but the meaning transcends specification, extends beyond metallurgy and geometry, speaks to larger truth about nations, about war, about the different paths to victory, about the price of survival, about the machines built when everything is at stake, when defeat means extinction, when winning requires total commitment of every resource, every person, every ounce of national will. The T-34 was such a machine, built in such circumstances, by such a nation, and the Americans who tested it understood, and wrote their understanding in technical prose stripped of emotion, in data tables and measurement records and ballistic calculations, but beneath the science lay recognition, lay acknowledgement, lay the warrior's respect for a worthy opponent, for a weapon that proved itself in the only test that matters, combat, sustained, brutal, total, and emerged victorious. The snow covers everything now, white blanket of winter, the tank disappearing into the landscape, becoming part of the frozen tableau, just another shape under snow, waiting for spring, waiting for dawn, waiting for whatever comes next in the long arc of history, the endless cycle of conflict and peace, of preparation and rest, of tension and release, that defines human existence, that drives the creation of weapons, that justifies the testing, the evaluation, the constant search for advantage. For edge, for the knowledge that might, someday, in some future conflict, make the difference between victory and defeat, between survival and destruction, between continuation and ending. The wind picks up, blowing snow across the proving ground, erasing tracks, covering evidence of the day's activities, resetting the landscape, preparing for tomorrow, for the next test, the next evaluation, the next captured weapon to be analyzed, measured, understood, the process endless, eternal, necessary, the price of security in a dangerous world, the cost of readiness in an uncertain age, the burden of knowledge in the atomic era that is dawning, that will dominate the rest of the century. That will make tanks seem almost quaint, almost innocent, simple machines of simple war, before complexity escaped all bounds, before weapons became too terrible to use, before the calculus of war changed forever. But that is tomorrow, that is the future, that is not yet, and tonight the T-34 sits alone in the snow, its moment in history past, its contribution made, its story told, crude steel and diesel smoke and rough welds that helped win the war, that proved adequate to the test, that survived the scrutiny of former allies becoming future rivals, that earned respect through performance, through results, through the inarguable logic of victory, simple and complete and final. The last light fades, the darkness is total, the snow continues falling, and the proving ground sleeps, and the tank waits, and the night passes, and tomorrow will bring new tests, new questions, new machines to evaluate, new threats to assess, new challenges to meet, but that is tomorrow, and tonight there is only silence, and snow, and the cold steel of a foreign tank on American ground, testament to the greatest war, memorial to the alliance that was, warning of the conflict that might yet come, standing silent in the winter night, bearing witness to what was learned, to what was tested, to what was understood, crude and simple and terribly effective, the T-34, Soviet steel, captured, evaluated, respected, remembered.